Hey guys, I'm Mr. Dave, and this is the RayKitty Science Project. And we do science here that you can do some hands-on stuff, and we do a little bit bigger projects. So we want you guys to kind of join in. Today, if you want to join in, we're going to be talking about waves and some of the things that you can get ready if you want to run and get ready. If you're watching this on live television, if you're watching this on television, you can run now. But the things that you would want are this stuff here. This is just some vegetable oil. And I have a bottle here that's about half full of water. Okay, now this bottle, I'm not sponsored or anything like that, but sparkling ice bottles are the best for science, okay? And that is because they're a nice clear bottle. They don't have any ridges in them, and they're pretty durable. Okay, so like I said, I'm not trying to promote any, push anything, but sparkling ice bottles are awesome for science. Okay, so like if you're at my house, the kids are like, "Dad, do I need to save this?" It's usually yes. So these bottles are wonderful because it has no ridges. Now, if you want to, you can also use like a 2-liter bottle for this, but you would have to have a lot of this. So we're just going to use this little bottle here, and one of these. Now, these are little flavor packets for your water. Here's a huge RayKitty science tip. Parents, teachers, this is a huge RayKitty science tip when you're looking up experiments, okay? When you're looking up, hey, let me find something fun for the kids to do. Let's do some science. They always say use some food coloring. Me, I don't like using food coloring. The reason is, it's actually kid coloring and clothes coloring and carpet coloring and all of those terrible things. These little flavor packets will color your items, whether it's paint or goo or slime or whatever it is that you're making. They will color it, and they're a lot less messy. Okay, so that's just a little RayKitty science tip for you parents and you teachers. Use these instead of the little droplets of food coloring anytime you can. So what we're going to do with this, because we are going to talk about waves today, is we're going to start just by making a simple wave demonstration. Okay? Now waves, when you think of waves, you think of like maybe the ocean, okay? Or you think of radio waves, or you think of like maybe this, hi, yeah, like this, hi. Now this kind of wave, is that what we're actually talking about? Yes. Wait. What? Yes. Yeah, we are talking about this kind of wave, okay? This right here is actually creating a wave, okay? So you can see that. Now all I have here is some nice purple ribbon and a stick, okay? Now I'm going to do the same motion as I was with my hand, and you're going to be able to see a wave, okay? Now you see that wave being transmitted down that piece of material, the same as when you're waving like this. When we're causing that vibration, we're causing waves, okay? Now, we're going to talk about hertz and the speed of waves and the amplification in just a little bit, but we are talking this kind of wave, okay? So, with our water here, we're going to open this thing up. Like I say, I have that bottle about half full. Does it have to be exactly half full? Nope. It can be wherever you'd like it to be in there, but you want to have plenty of room for your oil. Okay, now we're going to put this in first. This is not just to make it taste nice and blue, right? Whatever flavor blue is, but we're going to put it in here for the color. Okay, now you can see that turns it that nice, beautiful blue color. Okay, and this is way less messy than putting some drops of food coloring in there. Okay, so I'm going to go ahead and shake this around real quick. Just shake it around just to mix it. Okay. Now what we have here is that beautiful blue, and we are going to put our corn oil in there, or our vegetable oil in there. Now we're not really doing the density experiment. If you do want to kind of take this a little bit further at home, if you're teaching about density materials, that kind of thing, you can also go into talking about the density of materials with this one here, how our water and our oil aren't mixing, okay, so you can talk about polarity. There's a lot of different little experiments, demonstrations that you can get from just this right here. So parents, teachers, if you're looking at this, there's a lot of science that is happening in this crazy little bottle here. Now, Works way better if I put the water bottle lid on the water bottle. Okay, so we're going to get this one out of the way. And we're going to look at our bottle here. Now, when I do this, I'm going to squeeze it or squish it, which is a scientific term, not a real word. I'm going to squish it ever so slightly just to kind of get rid of some of the air in there, okay? And then I'm going to put that lid on. Luckily, I don't think I spilt any, so yay. That's way better than I usually do. Now, I'm handling this pretty gently. You may see in there that those waves are already showing up. But what we're going to do is we're going to turn it to the side here. And you're going to be able to see that beautiful wave in there. Okay? Now, that wave, we're going to be talking about the different parts of a wave. So when I tilt it here, you see that you've got those high crests, right? Or that antinode, and you've got that low point in the water, okay? Now, this is a surface wave, okay? A surface wave is any time you have two different materials and the wave happens in between them. The wave on the ocean, that's a surface wave. Most of that wave action is happening at the surface, in between the two. So when we see this here, this is a fun one. Like I said, I'm handling it gently now. But if you are working with kids or if you are a kid, you know that the first thing you're going to do when you have a wonderful thing like this is shake it, shake it, shake it, shake it. Okay, now, if you do, all that really happens is the water and the oil will tend to bubble around each other. It's actually a fun effect there. Another thing you can do with this is put a little bit of Alka-Seltzer in the bottom. Give it a shot. Make sure you leave it open because you can cause some problems there. But there's a lot of different demonstrations you can do with this one, but you see it separates right back up. Now, I just did it for that sake of demonstration. I wanted it nice and clear water and oil just for mixing. Okay, so I want you to envision this nice, peaceful ocean wave. Okay, when we're talking about our waves, because we are demonstrating that the waves have a crest, right, or an antinode, that's the little high part there, and our waves have got a node, right, or that little valley. So for the sake of science today, I'm going to pretty much refer to them as a crest or a peak and a valley, okay? So the peak is the high point and the valley is the low point. Okay, so this is an easy one that you can make at home. Again, there's a lot of science that you can do with this crazy little bottle of stuff right here. And the more you leave it, it'll kind of calm down. It's a beautiful little lava lamp thing, but there's a lot you can do with just this right here, but we're just using it today to demonstrate these waves. Okay, so now that we have your cool little wave jar that you made, we're going to set that one to the side, and we're going to get a little bit deeper into that. I didn't even intend that pun until I said it, but we are going to get a little bit deeper into waves. So I'm going to put this one over here. And now we're going to talk a little bit about the frequency of waves. Okay. Now frequency is how often something happens. Okay. I have a sine wave generator right here. Now a sine wave is this wave. Okay. When you see this wave, you see nice even curves all the way along, right? If I can get it, there we go. Nice even curves all the way along. And those waves are traveling very gently, okay? And so that curved wave is a sine wave, okay? Now, it's not sine like a sign on a billboard or whatever. It's S-I-N-E, okay? And that's just a type of wave, okay? You've got all different types of waves, but that's the one that we'll be dealing with most here. Okay, now another way to generate that wave or to kind of visualize what this thing is going to be doing is with a slinky. Okay, everyone knows it's slinky, right? This can go over stairs and downstairs and over your dog and all those kind of wonderful things. Oh no, wait, that's log. Okay, but anyway, so this thing here is a slinky. Okay, slinkies are awesome. Slinkies are a lot of fun. They're also a great way to generate a wave or to demonstrate a wave. Okay, so with this slinky here, I can kind of go like this. Okay, and you see, we have essentially one wave in our wave cycle there. We have that one crest or that one peak, and we have our two nodes, right? The small part or the part that stays still is our nodes or are our nodes, okay? So we have one crest and those nodes. Now, A slinky like this is fun for demonstrating waves, but it'd be way more fun if we had a giant slinky, okay? Whew. If we had a giant slinky. Now, a giant slinky is going to be way more fun for demonstrating that. And what I'm going to do is I don't even have enough room at this table to demonstrate with this giant slinky. So I'm actually going to move on over here. And so I'm going to bring this slinky over here now because I don't have enough space on that table for this giant slinky. Now, this giant slinky was donated to me by one of the awesome parents of one of my students. They're like, Mr. Dave, you need a giant slinky. And I can't argue with that. You always need a giant slinky. So what we're going to do with this giant slinky is I'm going to make some bigger waves. Okay? So I'm going to start by leaning it over the table there. It does walk downstairs. Yay! Okay, so we're going to come over here. And our giant slinky is going to give us some bigger waves, okay? So we're going to see a little bit larger waves with this giant slinky. Now, how long does this slinky go? I ran out of house before I found out. Yeah, this slinky goes so far. So we're not going to go real far, but we're going to go this far with this slinky. Now, we can see lots of those waves, okay? Now, this type of wave is called a transverse wave. Okay? A transverse wave goes across our material. Okay? It doesn't flow with the material, it goes across. Just like we saw with our liquid that we made over there for the wave, this transverse wave goes across the material. Okay? Now, we're going to get into a different type of wave, and I'm going to use this just to show you for now, but when we talk about it, that'll be what we're talking about, and that is going to be a longitudinal wave. Okay? Longitudinal is a fun word to say, but it just means we're going to go down our material. We're going to follow our material. Just like I'm rolling a bowling ball, you can see that little wave actually fall off of the curb there onto our little pile of slinky. Now this wave here doesn't move the material back and forth, it moves with the material. Okay? So a longitudinal wave is actually the way that sound travels and the way that we get a lot of different pressure waves. Okay? So I'm going to go back over to the table over here, and I'm going to pick up my giant slinky because, come on, I don't want to drop my giant slinky. Now, the problem with a giant slinky is one wrong turn, and you actually just have a giant metal bird's nest. Yeah, so I want to be careful with this giant slinky. I'm going to bring it back over here. Now, when we're talking about longitudinal waves, those are the waves that will go with the material, like sound. Okay. Now, sound is a fun thing because it kind of works with a little bit of both of the transverse and the longitudinal waves. But we are going to be now kind of visualizing, now that we saw on a large scale that transverse wave, we're now going to move to a smaller scale and show you a little bit about frequency. Okay. Now, frequency, instead of showing the crest or the peak in the valley, the frequency is how often that wave happens. Okay? So when we're looking at how often a wave happens, now the waves we're dealing with here today are mechanical waves. Okay? They're not electromagnetic waves. We're dealing with mechanical waves. And what I'm going to do is I'm going to bring this over here. Now, I've got a lot of stuff on the table today because I got a lot of demonstrations, and this is actually going to be like a two-part series on waves. So we will be demonstrating some of the stuff here today, and then we'll move along and demonstrate some of the other stuff next time we see you. So it'll be a big old cliffhanger, to be continued kind of thing, okay? So we saw our slinkies, and we saw that wave happening with our slinkies. What we have here is our sine generator, okay? When we were talking about a sine wave, okay, a sine wave means that this will generate a wave, just like we were talking, just like we saw that transverse wave that was happening in our giant slinky and in our little bitty slinky, okay? So this one will generate those waves at different frequencies. Now, I can generate a wave with a different frequency with my hands, but I can be like, oh, that's kind of fast or pretty fast, right? So this will actually show us exactly how fast. Now, what's kind of fun is these, let me ask my like super awesome camera guy, we're at 29.97 frames per second here, right? Is that correct? Yeah, okay, I thought so, yeah. So I wanted to make sure, because what's pretty fun with this is this little wave is going to do some strange things when I get around that frequency, okay? So we're going to be generating a wave with this machine here, and this wave is going to go across our material, right? And it's going to move up and down. So it's going to be a transverse wave, okay? So we're going to generate a transverse wave on our little string, okay? Now we're going to change the frequencies at which we're generating that wave. And we're also going to change the amplitude, okay? We're going to change how big that crest is. So if you have a slinky, or if you're like the hose is caught on something, and you're trying to kind of wiggle that hose to get it loose, and you give it a nice big wave, right? That's a lot of amplification or amplitude or volume, okay? If I talk very softly, I'm speaking at the same frequency, but it's a lot less volume, okay? So that's a smaller wave. Right now I have a very small wave. Now I'm at 30 hertz. I'm going to speed it up to begin with so we can kind of change it to see that fun stuff there. So we're going to start. You may hear a kind of a hum happening. Right now that hum is happening at 88 hertz. Okay, 88 times a second. This little thing is moving up and down. Now we don't see too much motion in our string right now, and part of that is the resonance. Okay, so we want to get to a frequency that resonates with our string. Okay, now certain frequencies are going to resonate better with our string, and it depends on if you pull that string tighter or looser that you can get a better resonance. Okay, now if you play any kind of stringed instrument, you'll know that you can play different guitars and things, and sometimes you will get a nice strong note out of a certain guitar, and they've got a certain note that resonates. To resonate means it's hitting the right frequency, and it is going to cause the most motion in the molecules around it, okay? So right here, we are now at 91 hertz, okay? And if you look with that camera there, you can see on your screen that we've got a little bit of vibration there. We've got some of those nodes, and you can kind of see it moving some, okay? Now, is it actually moving over here? Yep. We're moving at 112 hertz. We're going to slow it down, okay? Now watch what happens as we slow it down. When the frequency changes, our number of waves in our wave cycle also change, okay? So as we're lowering it here, okay, you can hear it going lower, and we're actually able to see, if you'll notice on your screen, there's also a fun thing that's happening with these little numbers right here, okay? You're going to notice that the numbers here are also flickering on that camera, and that is because of the frequency, right, the refresh rate. So we're going to slow it down. And there you go, I sped it up. Now I've got a pretty good number of little nodes going on here, and with that, let's see if we can get them nice, and there we go. So we can see that we have high points and low points, right? We have crests and we have valleys, right? Or nodes and antinodes. Now, you'll notice, especially in front of, you've got a fun little effect going on here. When this is flashing, look at the part of the string that is in front of our little lights here, right? You see that string kind of disappearing and reappearing in there? That's just a fun thing that's happening because of the frequency, right, or the frame rate of the camera. So when I get it right in front of that camera there, I mean right in front of these little lights here, you see how that string starts to do a fun little dance. Now, when we come down to closer to the frame rate of the camera, we're going to notice that string does some even crazier things, okay? We see that nice bouncing now, okay? Remember, I said that camera is recording, right? It's taking essentially a picture 29.97 times a second. Now you can see in the background here, we're right now at 45 hertz, right? So let's slow it down and watch what kind of starts happening with our string there. As we get closer, you see that string kind of doing a little stop motion, flashing back and forth in that thing rather than seeing a nice little blur from that string. Now we're seeing that string here, 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 here. We're seeing that little, like I say, it looks like stop motion because of the way that that camera is catching it at a different point on here, okay? So when we speed it up a little bit, we'll get a little bit more and we'll kind of show you those nodes again. So along the whole thing here, we've got, let me get a good refresh there. There you go. So when we look, we'll go right there. So now you can count along our string here. We actually have 1, 2, 3, 4, 5, 6, 7 of our wave cycles, right? So we have high points and low points. And so each of those is one wave, okay? And at 35 hertz, we're seeing that many waves. When we bring it up, now it's resonating better with the string where we're at, so we're getting a larger crest on there. And now we have 1, 2, 3, 4, 5, 6, 7, 8, right? Because we've upped that frequency, and you can keep going. And the higher you go, the smaller those little bitty waves will get, and we will get more for every little node there, okay? So we'll have, for every little wave, we're going to take up a little bit less space so we can travel all the way across there, okay? So what this is showing us, we'll do a little bit more with this machine next time. When we talk about waves a little bit more, we're going to use our plates over there. So we're going to turn this guy off and get him out of the way for now because that buzzing drives me crazy. No, but that sound there, humans, we can hear right around 20 hertz and up. Below that, we actually feel it, right? If you've ever been driving around and the car beside you, or if you're lucky enough, your car is going boom, 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 right? That is a low frequency, but a high amplification, right? You'll see those speakers bouncing and moving, right? If you've ever seen like Marty McFly when he hits that guitar in front of that big old speaker and it knocks him across the room, that's a very high amplification, okay? Now, we saw those little nodes getting bigger and lower depending on the resonance, okay? Now, what we're going to do here is I'm going to show you something with that resonance, okay? Now, resonance is, again, when a tone, a vibration, or a wave is resonating with the molecules around it, causing those molecules around it to do a little extra dance, okay? So that's called resonance. Now, this is an easy one to do at home. I've got some saran wrap or plastic wrap, right? And when you're doing this one here, the thing that you want to be sure of is that your material on the top is nice and tight, okay? So I'm essentially making a drum. Okay, so I have a little drum here, and I'm going to put a rubber band on it. Okay, so again, all you really need for this one is a cup. It doesn't have to be a plastic cup. It's a little better if it is a plastic cup because it vibrates a little bit easier. But I'm going to pull it nice and tight again. So I've got a nice tight drum on the top of my plastic cup. Okay, so you see that nice tight drum. What we're going to do is I'm going to get this stuff here. Now, this is very expensive. It's called rice. Okay, wait, no, it's not very expensive. It's just rice, just regular rice. You can use rice. You can use salt. There's a lot of different materials you can use for this, but I found rice is just a little bit more of a dramatic demonstration, okay? So what I'm going to do is I'm going to put some of this rice right on top of my cup. Okay, now for this, I'm going to cause the sound to come from my mouth, okay? So I'm going to be a little loud for this part here, and I'm going to try to vibrate that rice. and you're going to see when it resonates, okay? So I'm going to increase my volume, okay? Like that, okay? I have a terrible singing, yeah, okay. You'll hear more of my beautiful singing voice next time, because we're gonna, anyway, yeah. So when I go, right, it's not vibrating that rice. Even though that was plenty loud, it's not vibrating the rice. That's because that frequency doesn't resonate, okay? So I'm going to attempt to change the pitch, right, or the frequency of my voice in order to resonate that rice, okay? So I'm going to be making funny sounds here. I'm going to sound like I'm in a Tibetan temple somewhere and trying to write things, but I'm actually just trying to vibrate the rice. Okay, so here we go. Ready? It's a terrible sound, but watch. Oh, doesn't do anything. Oh, doesn't do anything, but listen to this. Oh. Right when I hit that right frequency, okay, I'll stop doing that, I promise. Right when I hit that right frequency, it resonates with my cup. And that causes our drum here to vibrate, okay? So the things that we talked about today are waves. We talked a little bit about the frequency of waves. We showed you some demonstrations with our little wave bottle here with some rice in a cup. And we learned about the amplification and the frequency of waves and what is a wave. Okay, so I'm Mr. Dave. This is the RayKitty Science Project. Huge thank you again to Studio 519. And don't forget, science shows you matter.